Okay. So I'm not going to make you do the antiderivatives or the integrals the long way, but I do need to give you the definitions and the theory. Okay. Antiderivative and the indefinite integral. So a function f, capital F, and is the antiderivative of lowercase f on an interval I, where the derivative of capital F is equal to lowercase f. And this is the mathematical symbols for all x in I. So it's just the upside down A here is for all x, lowercase epsilon means element of the set I. So just all the x's that live in this interval. All right, so here's a theorem. If capital F is an antiderivative of lowercase f on I, then we can call G, and G is an antiderivative second. Oh, I see. Yeah. And then G is an antiderivative of lowercase f on I if and only if capital G is of the form capital F of x plus your constant C. And this has to be true for all x in I, where C is just a real number. Any real number, some constant. G is called the general solution. Okay. You slow down a second. The operation of finding the general solution is called anti-differentiation. Or definite integration. And it is denoted by the integral symbol. So integral of lowercase f of x with respect to x is little dx telling us we're integrate this function with respect to x. That is equal to capital F of x plus c. So this is just the undoing of the derivative, the integration giving me the original function. This part of the integral, the f of x is called the integrand. The dx is telling you the variable of differentiation. C is a constant. I'll turn the page in just a moment. Okay. So I'm going to show you all the basic integration rules. So we can do it the easier way. Don't forget that the integration symbol and the derivative cancel each other out. So if I integrate the f prime, then I just get the normal function, but I have to add a constant. So I take a derivative of an integral with respect to x, and they cancel, leaving me with the original. All right. And here are the rules. Integral of a 0 is equal to c. Integral of k dx is equal to kx plus c, where k is an element of the real numbers. 3 k times f of x dx is equal to k times the integral of f of x. So you can pull out constants and deal with them later. Just so you can solve this and then multiply by k. Number 4, integral of the sum if you have a sum and difference of two functions, you can integrate them separately and then add them at the end. Number 5, this is the power rule. The one you're going to see the most. Integration of x to the n, so some power function is going to equal to x to the n plus 1 divided by n plus 1, and then you add your c. So whatever you have, just add 1 and divide by that same result. Number 6, here are the trig ones. Integral of cosine x dx is equal to sine x plus c. Integral of sine x dx is equal to negative cosine. Number 8, integral of secant squared x dx is equal to tangent. Number 9, integral of secant x tangent x dx is equal to secant plus c. Number 10, integral of cosecant squared dx is equal to negative cotangent plus c. 11, integral of cosecant x dx, actually cosecant cotangent. So you can tell I'm reversing all the derivatives, right? All right. Let's see if I can fit the rest here. Integral of a to the x dx is equal to 1 over ln a times a to the x plus c. Integral of e to the x dx is equal to e to the x plus a c. And last one, we'll put it up here, I guess. Integral of 1 over x dx, which is the same as integral of x to the negative 1, right? Is ln of x plus c. All right. That should be enough to start our examples. I'll wait for a sec.
I just need to finish writing all this down. Okay.
Example 1. Find the antiderivative of f of x equal to 2x cubed. So in other words, integrate 2x cubed with respect to x. So first thing we should do is move that 2 out of our way. So pull out the 2, and then just focus on the inside. So that was rule number 3. Now apply the power rule, which is rule number 5. Once you start to integrate or do the antiderivative, you no longer write the symbol. So 3 plus 1 over 3 plus 1 plus c. So this gives us 2x to the 4th over 4, which is x4 over 4, right? So it's pretty much the opposite of the derivative, right? So subtracting 1 and bringing it to the front to multiply, you're adding 1 and dividing by that result. Just don't forget your constant, because it's technically wrong if it's not there. Any questions on the first one?
No.
I have a question.
Mm-hmm.
So 2 suddenly disappeared?
No, which one?
The 2? So 2x, but there's no
Oh,
2x.
so here's an in-between step. So the 2 reduced, right? 'Cause this is 2 over 2 times 2. the 4. So reduce this.
Okay. Okay, I understand. Thank you.
Mhm. Okay, example 2. Find the antiderivative of f of x equal to x squared plus 3. So they want us to do this. Remember, rule 4 said we can separate these and do 2 separate parts. So this is the same as saying the integral x squared dx plus the integral of 3 dx. So now just do the power rule on this one. And then integrate this using, I think, rule number 1 or 2, I forget. That would be x to the 2 plus 1 over 2 plus 1 plus 3x plus c. When you separate it, I recommend just adding a single c at the very end. Technically, each one produces a c, but you can just relabel c1 plus c2 and let that equal to c. So it's just some constant. Doesn't matter. It would be determined by initial conditions, but we're not doing that right now. So just put it at the end so you don't mess it up. So it would be x cubed over 3 plus 3x plus c. Any questions on example 2?
No.
Okay. Now just let me know. Example 3. Find the general solution of dy dx equal to 3x to the 2/7. So we're doing the same thing, but this is basically a differential equation, but in a very simple form. If I want the general solution, you want to integrate both sides with respect to x. So these undo each other. Undoing the derivative means you get your original function back. This is the reason why we care so much about antiderivatives is we don't always have the original function. We have the derivatives. In real life, these are easy. The derivatives are easier to find than the actual function. It just depends what we're talking about. So on this guy, just do the power rule, and we'll have y. But I'm going to pull out the 3 in front, and then do it here. So add 1. Oops. I shouldn't be writing the symbol if I'm already beginning to integrate. 2/7 plus 1, that's 9/7, right? Divided by 9/7. We'll simplify this. You'll get 3 times 7/9, x to the 9/7. This will reduce, leaving us with 7/3, x to the 9/7. Any questions on this problem?
No. So far, everything's been easily explainable.
Yep, just let me know if anything's strange at any point. Let's do another one. The integral of 4th root of x dx. So don't forget that nth root means 1 over n power, right? So change this first. Then integrate. So you'll get 1/4 plus 1 over 1/4 plus 1 plus your c. So that becomes x to the 5/4 over 5/4, right? So divide by that fraction means you multiply by the reciprocal, getting us to here. Any questions on example 4?
Hold on, could you scroll up real quick? I need to write this down. Yeah, I ran out of space for my paper, so I have to go real quick to get some new one.
Okay.
Okay. Okay, scroll down a little bit, please.
And that's the whole page.
Oh, it's whole page? Okay,
Mhm.
it's probably my settings. Okay, I got it.
Okay. So don't let the homework mess with your head when they change the variables. It doesn't matter what they are. It's all the same as long as you're integrating with respect to that variable. Here we're doing theta. That's theta squared plus secant squared theta with respect to theta. So do one piece at a time. So you're going to get an integral for this piece plus the other one. Now, do you agree that this is just a power rule, right? And this is just from the formula that I told you earlier. Integral of secant squared is tangent, right? If you don't have that memorized. If you have the derivatives memorized, just go backwards. If you don't have either one, then just have them handy somewhere. So that's it. Any questions on example 5?
Well, it's all explained in the rules that you wrote out, so no questions.
Yeah, just remember the trig ones and the power rule.
Okay.
That's all we use there.
Okay.
I'll turn the page in a sec. All right. All right, two more examples and might be it for today. I'll leave the long one for Thursday. Example 6. So the integral of 3 sine x minus 7 e to the x dx. So what should we do first?
I would start with rule 7.
7 would be the trig property, but we have a difference.
Oh, okay.
So we should probably do 4 first.
Okay. Okay.
And then I think you're right. We'll have to apply it there. So 3 sine x dx minus 7 ex dx. So what is the integral? Pull out the 3 so it doesn't bother us. Pull out the 7. What is the integral of sine? Or the antiderivative of sine?
Is that a cosine?
Positive or negative?
Positive. Or negative? Negative.
Negative, right? Integral or antiderivative of e to the x should be the same, right? Like we expect. Your derivative is always the same. The anti should also be the same. Now we're pretty much done. Negative 3 cosine x minus 7 e the x plus c. Any questions on example 6?
Um, no. No questions.
So find the particular solution of the differential equation f prime of x equal to 4x, given this initial condition f of 0 equal to 7. So after calculus 2, you'll take a class called differential equations. If you're going, into STEM, or engineering or computer science or physics for sure. So you see a lot of these types of problems. So this is a very simple version of that. So we want to find the particular solution that has this condition. So this will help you find C basically. So when you find C, you have a particular solution instead of a general. Okay. So what you got to do is integrate to undo the derivative, right? Which would be integrating this guy. So that simply becomes 4x 1 plus 1 over 1 plus 1 plus your constant. So now we know that lowercase f is equal to 4x squared divided by 2 plus c, which is 2x squared. Okay. So at this point, use your initial condition. So remember, f of 0 equal to 7, that's the same thing as saying there's a point at 0, 7 that we care about, right? So use this to find c. So use the initial condition to solve for c. So f of 0 is equal to 4, actually 2 times 0 squared over 2 plus c. So this is equal to 7, right? That's what the condition said. If I plug in 0, it's equal to 7. So I plugged in 0, set it equal to 7. This ends up zeroing out. So that means that c has to be 7. So now the particular solution is equal to 2x squared plus 7. And this is what they want. Does that make sense? So you're not going to have a lot of these, but you'll have one or two here and there in the homework, but this becomes very important after Cal 2, if you're going that far. Cal 2 is all about, so you know how Calculus 1, I'm sure you've noticed, is all about derivatives, right? I'm hoping you've noticed that by now. Cal 2 will be all about antiderivatives, the integration, the entire class pretty much. With a couple of extra stuff, but mainly that. And then Cal 3 is both of them, derivatives and integration, but in 3 dimensions. Yes. You have any questions on any of the problems we just talked about?
No, it seems like all we have to do to solve these problems is just follow the basic integration rules.
Yeah, it's not too bad, right?
Right.
So when you get to Calculus 2, the first chapter is going to be a lot of this and a couple of extra things, and then after that, they'll show you all the other techniques. You know how when we got to derivatives, we had the power rule, we had the quotient rule, we had chain rule. You're gonna have a whole set for integration, which
Okay.
will be much harder than derivatives. All right,
All right.
guys. So we'll stop here. If you have questions, let me know. And if not, I'll let you go after I do the roll call real quick. Let me find it.